I am N.S. Venkatraman. I am speaking on behalf of Nandini Consultancy Center, a firm of chemical engineers and chemical business consultants based in Chennai and Singapore. It is now well recognized across the world that India is growing and making great strides in multiple directions. With regard to infrastructure projects, several thousand crores of rupees are being invested in railways, roadways, airport construction, seaport construction, and so on. There has been great, significantly improved progress with regard to the communication, services sector, and so many other related areas. In all these areas, with so much of progress, inevitably it happens that the demand for chemicals increase multifold. Now, India has set a target of reaching zero emission by the year 2070. To reach zero emission, what is required is the use of fossil fuels like coal, natural gas, crude oil have to be totally eliminated. The million-dollar question is whether it is possible. India presently consumes around 220 million tons of crude oil, and 80% of the Indian requirement of crude oil is met by import. India presently consumes more than around 30 billion cubic meter of natural gas, and equal amount of natural gas is being imported. Now, India consumes more than 700 million tons of coal. Obviously, to reach this zero emission target, all these fossil fuel use have to be totally eliminated. Now, the government of India is taking a number of steps towards and moving to achieve the target of zero emission by 2070. Of course, one of the well-known strategies of the government of India is to promote renewable energy and wind and solar power. Another important area where the government of India is targeting and moving forward is the promotion of electric vehicles. The government of India has put a very tall and ambitious target to increase the production of electrical vehicles in India. For the electrical vehicles, the important constituent essentially is the lithium-ion battery. And in lithium-ion battery, the important constituent is lithium-ion battery cell. And lithium-ion battery cell requires several chemicals like lithium hydroxide, lithium carbonate, lithium nickel cobalt manganese oxide, lithium ferrous oxide, cathode actives, anode actives, electrolytes, separators, and so on. For the anode, the important component is high purity natural graphite. This is the subject on which we are going to talk today. We are going to talk today on what is high purity natural graphite, what is the application, what is the process, what is the demand potentials, what is the investment possibility, what is the economic capacity, what should be the project cost, and what should be the price of high purity natural graphite. Now, before getting into all these areas, first let us have a look at outline of graphite. Now, the graphite's important characteristics is that it combines the characteristics of metallic and non-metallic. Because of this, the graphite has high level of thermal conductivity, thermal resistance, and also it can be used at a very elevated temperatures. Because of these properties, it finds use in several sectors like refractory, foundry, production of crucibles, paint, and so many other areas where graphite is being used. Now, let us look at the graphite. There are two types of graphite. One is known as natural graphite, other is called synthetic graphite. See, natural graphite is mined from the soil, from the graphite ore. When it is taken from the ore, normally it will have a fixed carbon content of around 7%. This has been upgraded. This is being upgraded in the beneficiation plant to increase the fixed carbon content of the graphite, natural graphite, to around 96%. Such plants are operating in India. With regard to the synthetic graphite, synthetic graphite is produced in electrical furnace using needle coke as the raw material. So both synthetic graphite and natural graphite can be considered as a complementary product. A lot of properties are similar. Some are not. Minor product properties are not similar, and they both are competing with each other in the application sectors. Now, having looked into this, let us have a look at the lithium-ion battery. what is lithium-ion battery? What is happening in this country with regard to lithium-ion battery? See, lithium-ion battery is an essential component of the lithium-ion cell. That is very, very important, without which you can't make a lithium-ion cell. Now it has several applications, vital applications. One is in the electric vehicles, like hybrid vehicles and all that, very, very important, like cars, scooters, everywhere it has to go. Secondly, it goes in the what we call a 3C, that is this computer and related communication sector. Third is the energy storage. These are the three vital applications of the lithium-ion battery. Now, in the electric vehicle, lithium-ion batteries requirement is around very high in the sense for the cumulative lithium vehicle requirement, lithium-ion battery requirement, if you find lithium-ion cell requirement is quite high. Now, given this scenario, what is happening with regard to lithium-ion battery in India today? Today, what is happening here is lithium-ion cell is not produced in India. Lithium-ion battery is being produced by importing the lithium-ion cell and assembling it in the lithium. That's something like a penalty-based stage of operations. The essential component is lithium-ion cell that is not being made in India. That's a very unfortunate situation. And what is the level of dependence of India today on lithium-ion battery? India is a heavy importer of lithium-ion battery and lithium-ion cell now. In the year 2020-21, April 2020 to March 2021, India has imported around 8,811 crore worth of lithium-ion battery and cell. In the next year, between 2021, April to November, India imported rupees 7,986 crore worth of lithium-ion battery and cell. That means the rate of import of this material between 2021 and 2022 has gone up significantly and substantially. This shows the need for producing lithium-ion battery in a very big way. And without producing lithium-ion battery, promoting electric vehicles may be considered as similar to the act of putting the cart before the horse. We have to, take care of the situation. Having seen about this lithium-ion battery, let us look at the natural graphite scenario in India. Now, natural graphite, as I told you, it is mined from the soil. Now, with regard to the natural graphite, what is India's availability? Availability of natural graphite in India is quite large, comes to several million tons right now. As a matter of fact, the reserves of natural gas, graphite right now in India is estimated to be somewhere around 7.84 million tons. This natural graphite is available in several states in India, predominantly in Arunachal Pradesh, Tamil Nadu, Odisha, and Jharkhand. But in all the other states also is available. Smaller quantities available, it remains absolutely unemployed or not adequately exploited. Against such a vast deposits of the natural graphite of 7 million tons per annum and more, India's production of natural graphite concentrate is only around 50,000 tons per annum. Natural graphite concentrate, as I told you, it's available. Graphite is available FC content, fixed carbon content 7%, is being upgraded to 96% the beneficiation plant. So this beneficiation plant product, what we call as a natural graphite concentrate, Indian production is only 50,000 tons per annum. So this is far less compared to the availability of this natural graphite in India today. Now let us look into this. Having seen this, now let us look into the other picture. Indian scenario for high purity natural graphite. We'll have a look at this. Indian purity. Before that, I will just explain one more thing. This lithium-ion battery has certain configuration components. It is anode, cathode, electrolyte, and separator. All four components are there. Now, this natural graphite goes in the production of the anode. Not only natural graphite, anode, this natural graphite goes. Along with this, there are also other products like tin, lithium titanate, silicon dioxide, they also can be used. But internationally, 96% of the anode metal used is graphite that is being used. In this, between these two, synthetic graphite usage is around 36% and natural graphite usage is around 60%, as high as 60%. Now, what is the difference between natural graphite and synthetic graphite and use of lithium-ion battery? Nothing much. Both have got a good thermal conductivity. But in the case of synthetic natural graphite, its crystallinity is better than the synthetic graphite. The other problem is the investment cost for setting up a synthetic graphite project is very high and it uses high energy. And further, it is also causing the possibility of environmental pollution. All these problems are not there in the case of the natural graphite. Therefore, internationally, you find natural graphite is considered as a more eco-friendly product than the synthetic graphite. That's one thing which you have to take into consideration. Now, let us look into this Indian scenario for high purity natural graphite. Now, let us look into this. As I told you, graphite is available adequate quantity in India, but the graphite concentrate is only 50,000 tons per annum. It is feasible to increase the production substantially. There is no technology constraint, or there is no constraint of availability of the graphite. But high purity natural graphite is not produced in India. Whereas we are going ahead with the huge electric vehicles, the target. We are now setting a plan for lithium ion cell. 2 or 3 plants are being promoted in India right now. Hopefully, they'll be ready by 2016. For this lithium ion cell that is going to be produced in India, we don't have high purity natural graphite to be used as anode. In spite of the fact that we have got enough deposits of natural graphite in the country, it shows the importance of the high purity natural graphite in production of lithium ion cell. As I told you, internationally, in the lithium ion cell, 96% of the anode that is being used is only high purity natural graphite. Is there not a bigger case for setting up a project for high purity natural graphite in India than this? Now, what could be the potential demand for high purity natural graphite in India? Let us have a look at it. Let us look at the relate to the electric vehicles. Now, the government of India is pushing forward with a great high target to achieve electric vehicles. Now, it wants to have around 8 crore electric vehicles on the road penetration level by 2030. It is fixing a target of 30% for passenger cars, 60% for the commercial cars, so many other things that have been said. For 8 crores of rupees electric vehicle you want to have by 2030, you imagine the requirement of lithium ion cell in the country. So given a conservative figure, finding out the level of this lithium ion battery cell, that project being put up, hopefully by 2016-17, the requirement of high purity natural graphite in India would be around 18,400 tons per annum. This is based on the calculation, 1.1 kilogram of high purity natural graphite is required for 1 kWh of cell. So Indian demand by 2016-17, hopefully if all the lithium ion cell project would materialize and more projects would come, it would be 17,800 tons. Now look at the global scenario. The global demand for high purity natural gas right now is around 0.74 million tons, 740,000. What this shows? This shows the high purity natural gas is not only going to have a good demand in India, it also has excellent export potentials. This we need to exploit, considering the fact we got enough graphite deposits in the country that need to be done. Now, having seen all this, important high purity natural graphite, the demand potential for high purity natural graphite, the fact that in the global market, internationally, for lithium ion cell, for anode, 96% of the anode is being used only in natural graphite, of which 30% is synthetic graphite and 66% is synthetic graphite, 60% is natural graphite. Huge opportunity is available. Then what are we waiting for? This is the basic problem. Now we are waiting for nothing. Enough opportunities are there. The opportunity is not being exploited. I just don't know why it is this. We are planning for lithium-ion battery. We are planning for electric vehicle. We are planning for lithium-ion cell project. And anode is a very, very important component of this. And nobody is talking about this high purity natural graphite project. This is what surprised me. This is what provoked me to do this webinar, to bring the national attention about the importance of setting a project for high purity natural graphite in India. Now, what is the process for high purity natural graphite? It's only a purification. See, we have to take the concentrate that will have around 96% of the fixed carbon content. It has to be pulverized, then it has to be purified, then it has to be coated. Some minor projects there, full of unit operations are there. I'm not going deeper into this. Now, this is the figure that is available. So, this process technology we don't have in India. I don't think anybody has worked on the high purity natural graphite technology development in India. Internationally, it is readily available. Large number of high purity natural graphite projects can operate in China, operating in Australia, operating in the USA. Only thing we are not doing it in India, because they have all realized the importance of high purity natural graphite, the growth potentials of the lithium-ion battery. So many projects are being expanded in China, Australia, and other places, anticipate a huge growth in demand for high purity natural graphite. What are we doing in India? We are not even having a looking at it. This is a very unfortunate scenario. This is, of course, unfortunate or fortunate, whatever it is, we should know the ground reality and move on. If you are going to do this now, this will be good enough. Now, what is the capacity we recommend? I have said that Indian demand could be well over 18,000 tons by 2016-17. By economic capacity and rough calculation basis, we suggest a project of capacity 7,500 tons per annum. The project cost will be around rupees 125 crore. And the price, commercial price of the high purity natural graphite in the global market right now is around $2.2 per kilogram. So economically, it will be worthwhile. Somebody has to get into this, study this, do a feasibility studies, and move on. If somebody takes interest in this project after listening to this program, I think the object of this program is satisfied. If somebody wants to have a feasibility study on this, they can approach us. We will try to help. Thank you very much.